Hello, Exercise Science. My name is Andrew Swan.
I'm Brandon Davis Perez.
We're going to be giving you examples of line of force as a little bit of clarification if you are struggling with this concept in biomechanics, both kinetically and kinematically. This will include free body diagrams, definitions, use, application, nomenclature rules, anything that will show up in class that you might be struggling with, or as Dr. Erickson would say, muddy points. We're going to be doing these examples now. When you're doing line of force has three different components in my mind at least. There are three phases when you're performing the analysis of the motion. You have essentially, in my mind, again, this is just the way that I look at it, but I think it's a helpful way to look at it. You have the first phase where you're looking at the task and the joint that you're looking at. You have the plane and the axis of rotation at which this motion occurs. And then you would have the force identification, which is like internal and external forces, which would be then, for the internal forces, the point of application would be something like your insertion or your origin of a muscle. But generally speaking, they want it to be in muscle groups for now. So we have the task and the joint, the plane and the axis of rotation, and then the force identification. From that, you get to the second stage, which is more of the action phase. This is where you're assessing the movement and you're actually looking at what's going on. You have two stages. This marker doesn't work. Two stages. The location of the vector in relation to the axis of rotation. Then the direction of the pull of the vector. So when I say the direction of the pull of the vector, it's important to know in line of force, the vector is the muscle or the vector is the muscle group. So if we're talking about glenohumeral flexion, the vector is the shoulder flexors. For this example that we're going to do, we're going to take specifically the anterior deltoid as the shoulder flexor. Therefore, the anterior deltoid is the vector. So from this phase, you have, in my mind, the phase of like your homework phase. You're setting yourself up to be able to perform the analysis. This is your preparation phase, then you have your action phase, and then you come back to whatever your task is. We're talking about glenohumeral flexion, so then you would just take that back down here and put it in his terminology, and you would just repeat it and say, therefore, blank torque. If we're talking about glenohumeral flexion, then it would be, therefore, glenohumeral flexion torque. If we're talking about glenohumeral internal rotation, then it would be GH internal rotation torque. Or, therefore, biceps supination torque. Therefore, in any relation, this last sentence is going to be, therefore, blank torque. So this is the current standing of how you assess line of force. So let's take glenohumeral flexion as the first example using this identification of line of force. I'm just going to move over here. Let's take the free body diagram of your shoulder from a side view. This is anterior to the shoulder. This is a side or lateral view. This is posterior to the shoulder. So this is your shoulder from the side. This here, as seen in the free body diagram, it is performing this motion of GH flexion. Right here on the shoulder, this is where you would put, well, let's work through it, the task and the joint. The task that we're performing is GH flexion, so we can change the task and joint at GH from task and joint to flexion at GH for the glenohumeral joint. The plane and the axis of rotation that flexion in this example specifically takes place is the sagittal plane, which has a medial lateral axis of rotation. So then we can take the second point, erase plane and axis of rotation, and replace it with sagittal plane and medial lateral axis of rotation. Let's move down to the location in relation to the axis of rotation. We just said a second ago that the axis of rotation is medial lateral for the sagittal plane shoulder flexion. That would occur right here. So we're going to put that as a dot right here to represent the axis of rotation in the free body diagram.
So if we were to look at Andrew here, if he's the person, and we were taking a view from this way, if he performs GH flexion here, the axis of rotation would go medial lateral. It would go straight through his shoulder joint here, and it's always going to be infinite. So our sagittal plane here is also infinite running this way. Our axis of rotation, medial lateral, is going to be infinite as well. And a good rule that we can look at and understand the relationship between axis of rotation and our planes is that axis of rotation always has to be perpendicular to that plane. So if you don't know the plane, you can figure it out if you know the axis of rotation. If you don't know the axis of rotation, you can figure it out by using the plane. Does that make sense?
Yes.
Excellent.
Another point that Brandon mentioned earlier, which would be helpful to figure out, is when you're drawing a free body diagram, the axis of rotation should always only look like a dot. The axis of rotation is infinite, and as he just said, the axis of rotation for the sagittal plane shoulder flexion infinitely goes from right to left. But if you were to look at it from this angle, you would only see a dot because it's infinitely going this way. So therefore, when you're drawing a free body diagram, you should always take the view of the axis of rotation. The view of the axis of rotation is medial and lateral. That's why we have a lateral view for the free body diagram. Okay? So, the location of the vector in relation to the axis of rotation. Here's our vector. It's right here. Let's draw the anterior deltoid, specifically anterior deltoid, as this fiber right here. Here's your medial lateral axis of rotation. And how would you travel then from, this is the shortest line from the axis of rotation to the vector. That shortest line from the axis of rotation to the vector, we call that the moment arm. So you take the moment arm from the axis of rotation to the vector, and in this case, generally speaking, it might be a little superior, but the shortest line from the moment arm would be primarily just anterior. So this green line here is the moment arm. Again, shortest distance from axis of rotation to the vector. And again, the vector is the muscle. This location in relation to the axis of rotation is anterior. So now we have location. The location of the vector located anterior to axis of rotation. Now we have the direction of the pull. The direction of the pull of the vector, the insertion point of the deltoid is the deltoid tuberosity right here. Deltoid tuberosity is pulled via the anterior deltoid closer to its origin point of the lateral third of the spinous, or lateral third of the clavicle and the acromion. That's for anterior deltoid. So the lateral third of the clavicle and the acromion, so here to here, and this distance is shortened in GH flexion. Therefore, it's being pulled this way. So this pull, if you were to be represented as the marker, this pull is a...
I'll use this for the vector, different color. Moment arms.
I don't know if this one comes up.
Oh, I don't know.
Let's see. This, the vector, and the direction of the pull from the vector, if you were to look at my body, in relation to my body, the marker is pointing what way? The marker is pointing backwards and up. We call these directions anterior, posterior, so that would be posterior, and then we can also call it superior versus inferior. It's going upwards, so it's superior. So the direction of the pull in GH flexion by the anterior deltoid is posterior and superior because it's going backwards and up in relation to my body. That would be represented, oh, no. If you can see that, if not, I'm going to write it in black. That is the direction of the pull. So the direction of the pull by the vector is a posterior superior pull. And then, as I said before, to get the final step, which is just your answer, you're just going to come right back up here to your preparation phase where you set yourself up. You did your homework and you know exactly what to say at this point. We're talking about GH flexion. You did the answering and the analysis of the movement, and you said the location is anterior to the axis of rotation. Correct, because the moment arm moves primarily anteriorly from the axis of rotation. The direction of the pull is a posterior superior pull, because as you see, posterior is this way, the vector is pulling posteriorly, it's also pulling superiorly. You did your homework, and then you did your analysis. Then you can sit back, relax, and just say, therefore, GH flexion torque.
Okay, so now that we did an analysis of a movement, we now have to explain why that movement occurs. So with the example that we just did, GH, glenohumeral flexion, well, we knew that the anterior deltoid produced a GH flexion torque. Okay, well now we have to put it into a sentence and understand really why that happens. So again, if we were looking at GH flexion happening in sagittal plane, it would have a medial lateral axis of rotation. Okay, we have that down. Perfect. So our nomenclature rules for our extremities, our arms and our legs, including the girdles, our rule here is the movement is described for the anterior surface of the distal segment relative to anterior surface of proximal segment or body midline. So what does this all mean? So at a joint, we know that multiple bones articulate at that joint. GH is named for the two bones that articulate at that joint, the glenoid and the humerus. So distal segment would just be the most distal bone. In this case, the humerus is the entire distal segment. So we would say anterior surface of humerus. Okay, so we're getting part of our sentence down. Relative to the anterior surface of proximal segment. Well, we just found out that the humerus is the distal segment. That G in the GH stands for glenoid. So our glenoid is going to be our proximal segment. So anterior surface of humerus relative to anterior surface of the glenoid. Or in this case, you could even just say the whole scapula or even just body midline. But here, since this motion, it would make more sense to say where the humerus is relative to the glenoid. In some situations, if we're talking about different scapula movements, it would make more sense to say body midline. But let's just clear this up so we have the rules down for this example. In GH flexion, the anterior surface, if we're looking at anterior surface here of the humerus, anterior surface of the humerus, which is the distal segment, relative to the anterior surface of proximal segment. Well, which way does it move? Anterior surface of the humerus moves anteriorly, it's moving forward, and superior, relative to what? Relative to the anterior surface of what's our fixed proximal segment, our glenoid, or body midline. In this case, we're just going to say glenoid. So, put this all together. Again, recap. GH flexion occurs because the anterior surface of the humerus moves anteriorly and superiorly relative to the anterior surface of the glenoid. That's how we would use our nomenclature rules to describe GH flexion. Alright guys, so that was our...
Give me some space.
Stay in front.
Sorry.
Alright guys, so that was our comprehensive video on force vector analysis for kinetic movements, as well as applying the nomenclature rules to those movements. So basically what we're doing here is our plan is to make these videos more frequently, and you guys let us know what you like about it, what you don't like about it, and we'll change it up as we go. And hopefully for you guys to find these videos helpful, y'all watch it, and then you let us know what you think. Andrew, anything to add?
Obviously, if you have any questions about the examples we went over, if you'd like further help, you can reach out to us personally. Again, I'm Andrew Swan and Brandon Davis Perez. If you have any questions, feel free, and thank you.